Okay, this is the second part of that video on lesson 6, probability. So we're going to use that formula we have. Let me get my little pen there. But we can use that multiplication rule for independent events. Only works if you know the two events are independent. Now we spent I forget which lesson it was, trying to determine if two events were independent. But sometimes from reading it, you know that the two events are independent. If you have a number cube which has face numbers 1 through 6, and a coin has two sides, heads and tails, if you roll the cube or if you flip the coin, they're completely independent of each other. They're two separate events. There's no way that they can be related. Okay. The number cube is going to be rolled and the coin is going to be flipped, and the probability the cube shows a 4 and the coin lands on its head. Okay, so you want to find that probability. Because the events are independent, we can use the multiplication rules we just learned. Okay, so if you get the probability the cube shows a 4, so that's actually 1 out of 6 times the coin, 1 out of 2. It's 6 because there's 6 possibilities on that number cube, and you're getting a 4, which that's 1 of the 6. The coin, there's 2 possibilities, you're getting 1. It's actually going to be 1/12, which is equal to, we're just going to leave it as 1/12. Okay, and you could put that in a decimal and put it in as a probability. Okay, if you toss the coin 5 times, what's the probability you will see a head on all 5 tosses? Well, I toss it the first time and I get 1 out of 2. Okay, now the next event has nothing to do with the first one. It's completely independent. And I'm going to toss it 5 times. What's 2 cubed? That is 1 over, let's see, 2 to the 5th would be 32. I'm going to get my calculator out on this one. It's going to be 0.03125. Okay, if you toss the coin 5 times and got 5 heads, would you think that this coin is a fair coin? No way. I would say no. Okay, although getting 5 heads is possible, look how the probability is 0.3% probability that would happen. So I would say no, the coin is probably not fair. You're cheating me, you're trying to get all my money. Now, if you roll the number cube 3 times, what is the probability that it will show 4 on all 3 throws? Well, it'll be 1 out of 6, 1 out of 6, 1 out of 6, and I'm gonna get my calculator out for this one, and I'm gonna get 0.005. So if you roll the number cube 3 times and I got 4 on all 3 rolls, would you think it's fair? No, you're cheating me. Okay, I just don't think that there's any way, because look at the probability of getting a 4 on all 3 rolls is extremely small. So, I'm going to think you're cheating me. Okay? Okay, let's look at some other examples. Okay, suppose that the credit card company introduces an exercise 1 states when a customer is selected at random, the probability that the customer pays his bill in full each month is 0.35. The probability the customer makes regular online purchases is 0.83. And they have to tell you, because there's no way I would know whether that was true or not, they are independent. What is the probability that a randomly selected customer pays his bill in full, 0.35, and he makes regular online purchases? I'm going to multiply them together. And what do I get? I get 0.2905. That means 29%. That's pretty good. I think that's pretty good. So it tells you this is the probability the randomly selected customer pays his bill in full each month and he makes regular online purchases. Well, you look at that, you might be going 29%. That's not very many. Well, I'm thinking it's pretty good knowing how much credit card debt a lot of people have. But 30% of the people buy it on the credit card and they pay it in full each month. I am part of that 30%. Okay. Let's try another example. Oh, it's the spinner. I love the little spinner guy. Okay, spinner has a pointer, and when the pointer is spun, the probability that stops in the red section of the spinner is 0.25. Did they give me what does the spinner look like? What do I know? Okay, let's look and see. Maybe I forgot to put something in on this one. Okay, spinner has a pointer, pointer spun, probability that stops in the red is 0.25. If the pointer is spun twice, what's the probability that will stop in the red section on both occasions? Well, I guess I don't even have to know very much to know that would be 0.25 times 0.25, 0.0625. If the pointer is spun 4 times, what's the probability that it will stop in the red section on all 4 occasions? 0.25 times 0.25 times 0.25 times 0.25. And if I put that in my calculator, I'm going to get about 0.004. If the pointer is spun 5 times, okay, oh no, that's 4 times. I think I'm messing this up. Spun the probability, oh, I'm skipping. This one's for if it's spun twice. This one's if it's 4 times. Let's go down here. If it's spun 5 times, what's the probability that it never stops on red? That it never stops on red. Well, I'm going to say if it's the 20.25 that it stops on red, then what is it that it never stops on red? Wouldn't that be, I'm going to use my complement rule, 1 minus 0.25 is equal to 0.75. So I would say 0.75 times 0.75 times 0.75. Ooh, this is going to be a really, it's going to be a little better. It's going to be 0.237. Okay, that if it's spun 5 times, the probability that it never stops on red. And I used my complement rule there to say that's 1 minus 0.25. So they didn't even have to tell us what the spinner looked like or what else was going on. But it obviously was a big spinner with, you can look at it this way, and those were all red, and I don't know what these colors were. They didn't tell us. And you got the spinner. Let's try another one. Oh, nope, that's all they're going to tell us. Okay, this video has, the complement, not A, 1 minus the probability of A. We've used that now in 2 lessons. This one's really nice. For any 2 events, A and B, if you want to do conditional probability, instead of having to do that 2-way table and figuring out, look, here's your formula. If you happen to know the probability of A and B, you can divide it by A, and it would give you that conditional probability. If A and B are independent, and that's if and only if they're independent, the probability of A and B, you can multiply them together to get the probability. Okay, good luck on your assignment.